and then on the next line we print OK1 and a bit of diagnostic information. So we're going to end up with either OK1 or not OK1 for our test. And that's our first test that's gone through there. And then we do our second test. We call this method on our reader, which is our first line, and we want to check that it equals start. So if it doesn't, we print out our not here, and then we print out the OK and a bit of diagnostic information. So at the end of here, we either have OK2 or not OK2. So this is a very simple way of producing tap output. But already we can see, even in these 10 lines, that it's not very nice. We've got this horrible print not unless stuff that's repeated twice here and obviously needs to be factored out. We have to keep track of our test numbers, and we're going to have to reorganize them if we need to and stuff. It's all kind of horrible, so it's not going to scale much beyond this sort of size. So in Perl 5, anyway, we have test.pm, which was the kind of refactoring of this kind of stuff to make it work. So we can see we still have a script here, but we're using the test module. We're using our reader again, and at the beginning we have this function, this subroutine called plan, and we can tell it we've got 2 tests. And so that's going to print out our tap for that, so we don't have to print out the tap ourselves. The module knows how to do it. Then we create our reader, and we just have this subroutine here called OK. And if our reader is a true value, which undef isn't and an object is, then that's going to pass the test, otherwise it's going to fail. We get our next line, and then we have our OK module here again, method or function here again. And we can say our first line, we want it to be start, and the OK function will test that, and we have a bit of diagnostic information. So this saves a lot of the problems that we had before, solves a lot of problems. But you may have noticed we've lost a bit of information here. We don't have any diagnostic information on OK, because we only have this one function here, OK, and it takes a number of parameters, and this parameter here, the diagnostics, is optional. So if we have diagnostics here, we wouldn't be able to tell the difference between whether we're comparing 2 strings or if we have a Boolean and a diagnostic. So it solves some problems, and it's brought some other problems along with it. So then we have test simple, which aims to solve some of these problems. So we save a line here by specifying the number of tests when we do the import. So here, this is exactly the same. And in the OK subroutine here, we can now pass our diagnostic output. And in the OK down here, we can't pass in 3 parameters. We have to do the test ourselves and then the diagnostics. So we've solved the problem that we didn't have any diagnostics up here. But what we've lost is that we have to do the tests ourselves here. And that means that if the first line is not start, we can't have any diagnostic information to tell us why our test has failed. So yeah, ups and downs. So we have test more. And test more solves this problem. So this is all the same up here. This bit's all the same as well. But down here we have a new function called is. And here we can pass in our 2 strings, the string we got and the string we expected, and diagnostic information. And if this doesn't match, it's going to tell us, well, actually, first line should have been start, but we got end or whatever it was. So we get a bit of information there. And test more works well with numerous other testing modules. So often we want to do more than just testing strings. We might want to test some data structures that are fairly deeply nested, for example. Or we might want to test that when we call a function in a certain way, we get a warning coming out. So there is extra modules that we can hook in with test more to solve that problem. But the problem there is that you end up with a bunch of boilerplate coming up here at the beginning of every test that you have, and that's a bit of a pain. So someone, I think Curtis, came along and created test most. And you maybe didn't see much difference as I flipped over the slides. Test more, test most. The only difference here is actually the name, and that's because I'm not using any of the features that test most brings us. But test most also pulls in a bunch of common testing modules for you so that they're available and provides a bit of extra functionality. So if you're planning on using test more, you may as well use test most if you need some of that functionality. Okay, so we've looked at a few different test modules, and up to now they've all just been scripts, and it's been fairly basic. But there are other ways of testing as well. So in the rest of the world, you have XUnit and JUnit and things like that. And of course, you can do that in Perl as well. So we have TestClass, and immediately we can notice that this is a little bit different, right? So we've got a module here. We're not running a script. So we've got our reader test module, which is inheriting from TestClass, but also using test more. And we can also see we've got subroutines down here rather than just our plain script. And let's take a quick look through some of these things. So we have a subroutine here called make fixture, and it's a setup test. And what this tells us is that this subroutine is going to run before every other test subroutine and can be used to set things up. And there's subroutines, methods that can be used to tear down things afterwards. So in ours here, we're just we've got our object, and we're just setting the reader element in there to be our reader. And then when we come to our test here, we're saying there's two tests in this subroutine. We read our reader that we've just put in up here, and this bit here is familiar to us. That's the same as we have with the test more and test most code. So that's our module. Of course, modules we can't just run on their own, so we need something to go around it. So we have a little script here, which is just going to use that module, and is going to run the tests in it. So that's TestClass. It does a lot more than that. I mean, you may think, well, why do I need all this? You know, my code's gone from 8 lines up to 15, well, plus more, because I even have 2 files. But you get a bunch of other benefits coming with that, which I'm not going to talk about right now, because I'm going to go and talk about TestClass Moose, which I think is also yours, right? Yeah. So here, similarly, we create a module, and instead of inheriting from something, we just use TestClass Moose. And as you might expect from a name here, Moose, we get a bunch of Moose goodness that comes in with that. So we can specify our reader here. It's a read-only object, and it has to be a reader. And we also have these 2 subroutines here. These 2 methods are similar to the 2 we saw before, but they're the syntax is kind of nicer. It's more sugary. It's easier to understand, and then we can use the Moose parts here. So in our setup, we set the attribute here. We use it, and then this is the test more stuff again. And similar to TestClass, we also need a little driver to sit around that and to run it. So everything we've looked at so far, with the exception... Okay, I'm a little bit late. I started 5 minutes late. Do you mind if I go 5 minutes over? Or do we have another one coming straight after? I'll try and fit in as much as I can. Yeah. Behind the scenes, there's Test Builder, which is a module which everything is hanging on. And Test Builder has a number of deficiencies in the design, which make a number of things difficult to do. For example, quite often you might want to end your entire test suite if any test fails. You say, as soon as something fails, that's it. I don't want to test anymore. And you can't really do that with what we've looked at so far. You might want to fork your tests, and it's not easy to do that and pull everything together again. So previously I mentioned about, when we looked at the producers, I mentioned about test2. And so there's also, when we looked at consumers, so there's also a test2 producer. And what's happened here is that the test harness, the test builder part has been pulled out and refactored, and the architecture has been significantly increased to solve a number of these problems. yeah, let's look at some test2. You see we're back to using a script again. Test2 bundle more is kind of the equivalent of the test more parts. So we get similar kind of functionality. We're planning to here. We can't do that on the same line, but we're planning it. And then this code here is exactly what we'd seen before. So you may wonder, well, what's the benefit? But as I say, it's in the architecture and what else it can bring you. And I think that test2 can also do a lot of the stuff that the TestClass and TestClass moves can do, if I understand correctly. Do you know, Curtis?
I haven't played with test2.
Okay, I think it can. Yeah. So you have another option there. Okay, so now we get to the million-dollar question. Which of these should you use? And this is where I say opinion is divided on the subject. I'm going to try an experiment here, and I don't know if it's going to work because we haven't got any sound hooked up. But I'm going to show you a 30-second clip of one of my favorite programs, which some of you will know about and some of you won't, and which is a UK comedy program called Blackadder. And in it, Rowan Atkinson plays Blackadder. And in this particular episode, it's set in Elizabethan times, and he's chartered a ship to sail around the Cape of Good Hope. And the captain of the ship, Captain Rum, is sitting here with Blackadder, and they're trying to discuss how they're going to get around the Cape of Good Hope. And are we okay to play that? I've just turned the volume up on my...
It's fine.
Yeah, okay. We'll see if it works. I hope it does.
I'm not running it.
Okay, so I feel a little bit like Captain Rum here now. When I'm going to tell you which one to use, and especially with Curtis sitting in the room as well. But so there are two thoughts about the actual tests, right? One is to say it's just a test; it doesn't matter. It's just a script. Chuck it in there, and it works. The other thought is that tests are code, and we should apply the same engineering rigor to our tests that we do to everything else that we work on. Sorry, what time do I finish? It's 45 minutes from 22, right?
About 25.
25. Oh, good. I thought it was quarter past. Okay, all right. I won't go over. Okay. Good. Those seem like they might be in opposition to each other, but I actually agree with both of those. And maybe I'll try and tell you a little bit what I mean by that. Curtis has a talk this afternoon, I think, busting testing myths. And I wrote to him in Twitter, I'm half expecting him to tell you that half of what I say today is absolute rubbish, and that's fine. But I'm going to tell you a few things about what I think anyway. This is a quote, it's a parenthetical aside in test.pm from Joshua Prudkin, who wrote test.pm, which we saw earlier. And I quite like it. Your test code should be simpler than the code it is testing, yes? And I like that thought. I personally don't want to be debugging my testing code. I don't want to be debugging any code, actually, but I'd much rather be debugging the actual code I wrote than the tests that I've written. Yeah. So that's where I am sort of on this scale a little bit. So I'm going to go through the tab producers here. It's nicer, and it lets you do a lot of nice things which you just can't do with all these other ones up here. So my recommendation, for what it's worth, and take it with however many grains of salt you want to, is that test2 is wonderful and can do pretty much anything you might want to do up here. If you're really quite risk averse, then I would recommend test most. And if you really want to jump into your testing head first with both feet, that doesn't work, does it? But if you really want to jump into it with all your software engineering practices, then TestClass Moose is probably where you want to be. Okay, good. So that's writing your tests. Now, what often happens is you write your tests, And then somehow you can be a bit dissatisfied with them because they're not bringing you everything that you'd hoped for whatever reason. And so I want to talk a little bit about some common problems that we might find with our tests, and perhaps some ways of getting around some of those things. So one common problem is I don't trust my tests. You might have a test suite, you run it, everything's green. Oops. Everything's green, it works, you ship code, and then you get bug reports. Yeah? So what's going on there? Well, a few things perhaps. So maybe your tests are not covering a great deal of your code, right? If you're only covering a fraction of your code and the bugs are coming in from the bit you've tested, then that means your tests aren't very good, right? You need to fix up your tests. But if the bugs are coming in from the parts that you haven't tested, well, that's not surprising, right? Because it's not really been tested. So you know where to put your effort in that case. And increasing the coverage can help you there. If you do have a reasonable high coverage, but it's just a nagging feeling in the back of your mind, then there's not much more really than just releasing it and seeing what happens. And maybe over time you don't get many tests coming in, many bugs coming in, and you can say, okay, I really should trust my test suite a little bit more. If you want to move to something like continuous deployment, you have to have an implicit trust in your tests. So you need to make sure that your test coverage is high, and you also need to know that over time it's proven itself. You can release stuff and not get a bunch of bugs coming in which haven't been caught by your test suite, even though your coverage is quite high. So there's one potential problem you might have. My tests are too slow. So the point about tests is that when you're writing code, you want to be able to run your tests straight away, and you want to get quick feedback. If you don't get quick feedback, then what's going to happen is you're not going to run the tests regularly, or when you've changed a bit of code. You might save them to run overnight on the CI system, or you might save them to run just before you're ready to do a release or something. And by that time, when you get a bug report or one of your tests fails and you have a look at it, you've forgotten what you were working on. If you get the feedback straight away, you're right there, you know what you're thinking, you know why you've done it, you know which bit of code you've changed, and you can easily work on it. You get a quick iterative cycle. If your tests are too slow, you lose out on that. So your tests really need to be quick. So one solution is just to chuck hardware at it. Right? Most of us, I think I have 12 cores in this machine here, most of them sitting there doing nothing, right? And so every so often I can just run all my tests in parallel. As long as your tests are independent, and so you don't have to run a setup test somewhere in order that you can run subsequent tests. So if you like that, run them all in parallel, that's great. If you do have a few that need to be run sequentially, I think Prove has a rather undocumented way of specifying that to a greater or lesser extent, really. So it's still possible to do things there if necessary. Maybe they're still too slow. What do we do when any bit of code is too slow? We apply our software engineering rigor to it, and we optimize parts of it, right? Before we optimize parts of it, we always profile it, right? Run NYTprof is the thing to use here. And if you run it on your tests, it might tell you that your test is too slow, or it might tell you that the code you're testing is too slow. Either way, it's good, and you can optimize it, and you can speed things up there, hopefully. Sometimes you might find that you've got a bunch of small tests, and the time is being taken continually pulling in your environment in order to test. So you use a module, and that does a bunch of stuff. Maybe sets up database connections or whatever, and it gets quite slow. So TestClass has a mode in which, I think it's TestClass, right, or TestClass moves?
Both TestClass and TestClass moves will allow you to run all your code in a single process.
Exactly, yeah.
You want to make sure you have a single driver script. Other people used to be writing separate driver scripts, not scripts for each VM file.
Yeah, you need to have one, exactly, yeah. So with TestClass and TestClass moves, you can get all of your tests running in a single process, which saves on all this tear up and maybe start up and tear down time. And if your tests are amenable to that, that can be a good way to get a nice speed up on your tests. And DRY, don't repeat yourself. How does that apply to testing? Well, quite often you might have a test suite where you've got a bunch of tests all doing basically the same thing. If you have a test that's only testing things which are already tested in other tests, you don't need it, right? So you can, if you go through your test suite, you might be able to eliminate a number of tests, or you might be able to simplify various tests so that you're not going through a whole process of testing. You're just testing a little bit that you're interested in. So that's testing, slow tests. Anyone ever have this? Yeah. So you change your code, and then all your tests start failing, and you have to go back and fix them. And no one wants to do that, right? That's a real pain. So you either you think to yourself, I really don't want to change that code because I know I'm going to have to go and mess about with the tests, or you leave the tests failing, or you turn the tests off or something. I mean, there's nothing good comes from this, right? So I have a contention on this, which is that when this happens, often it's because you're testing at the wrong level. And I'll tell you what I mean by that. So about a decade ago maybe, there's a chap called Mike Cohn who wrote a book, something Agile, Success in Agile maybe, or something like that. And in it, he introduced this concept of a testing pyramid. And this is what it looks like. So the idea here is that at the bottom of the pyramid, which is where most of the work happens, you have your automated unit tests. And maybe that includes about 80% of your test suite, for example. As you move up, you have your integration tests and stuff, which they are more brittle because they're testing APIs and things, and they also take longer to run. So you need a few of those, but you don't need as many, 15% of your tests maybe or something. And then at the top level here, you have your UI tests, for example. Maybe this is where you pull out Selenium and you run it against your UI. And as you know, that's going to be very brittle, right? Anytime anything changes in the UI, you're going to have to rewrite your Selenium tests. So you don't want very many of those, but you do need to test some things at that level. And then at the top, maybe you've got your testing the manual parts. So this is the kind of the idealized way of structuring your tests. However, most people don't have that. Most people have the inverse, which is the ice cream cone of testing. Right. So you have a few unit tests down here, a few more integration tests, lots of stuff done in Selenium, and then you need a big manual regression testing step at the top because you don't trust any of this stuff here because it's too hard. So what happens here is that when you've refactored your unit, you haven't really got strong unit tests, so you're not catching the errors until you get up to, say, your Selenium tests. And then, of course, it's going to be a pain. It's a real pain to do that. Or even worse, you may be only getting them in the manual test. I mean, you've got an enormous loopback cycle here. So your tests should be like this. They end up like this. And that means that you're testing at the wrong level. You're using UI tests instead of unit tests, for example. So that's one possible reason why you have to fix your tests after you do a refactoring or something like that. There's another reason which sometimes crops up, and maybe some people like doing TDD. It was advocated a few years back, and maybe it still is a bit today as well, to a certain extent. But some people have sort of thrown. There were 3 original rules of TDD, but other people have thrown other rules into how that works. So you might hear that every time you write a class, there needs to be a test for that class, perhaps. And further, you might hear that every time there's a method in that class, there needs to be a testing subroutine to match that method. And if you do that, that's when you're going to get problems, because what happens is that you're going to have your tests very tightly coupled to your implementation. So when you come to refactor, you refactor the code, you're going to need to refactor the tests as well. And that's going to be a pain. That's going to slow you down. And it's also not very good because when you refactor, you don't want to be changing the tests. The tests are there to stay constant to let you know that refactoring has worked. So what's happening here is that you're testing the implementation rather than the API. So every time you have a class, implicitly or explicitly, there's going to be some sort of an API to the world to use that class. And that's what you need to be testing. And if you test that, then when you refactor that class, as long as that API stays the same, which is what it should do if it's just a refactoring, then your tests are going to keep passing, and when you've refactored, your tests pass, and you know that you've done the refactoring well. Yeah. So that's one way that your tests can drag you down if you're not working that way. They can be a bit, rather than being the wind beneath your wings, they're a millstone around your neck, right? So it can happen sometimes in test suites. So I've come to the end of my time. So the important thing is to do your tests, but to try not to fall into any of the pitfalls that mean that once you've done your tests, they are slowing you down as you move further along the life cycle, rather than helping you increase your velocity as you get further. I think that's the end. Yeah, I've got to the end. So I will, I don't have time for questions now, but I will be around the conference for 3 days. That's the advantage of speaking right at the beginning, right? The disadvantage is that the projector doesn't work, but the advantage is you can come and find me for a couple of days, and happy to talk about any of this. So thank you very much.